Boeing has been one of the largest aerospace manufacturers in the world since its founding in 1916, renowned for providing top-quality aircraft and reliable solutions in the aerospace field. However, recently the company has faced significant challenges, especially with its Starliner spacecraft. The latest issue arose while Starliner was docked at the ISS, encountering technical problems. Attention is turning to SpaceX as a potential solution. However, no final decision has been made about who will rescue Starliner, whether it will be SpaceX's Dragon or another option. So what exactly went wrong, and what are the possible solutions? Stick around as we explore Starliner's difficulties and the potential paths forward. The Starliner mission launched on June 5th and was a critical test flight designed to validate Boeing's capability to transport astronauts to the International Space Station, ISS. This mission, part of NASA's Commercial Crew Program, was intended to demonstrate the safety and reliability of Starliner for future operational missions. Upon launch, Starliner successfully reached orbit and docked with the ISS, marking a significant milestone for Boeing. However, shortly after docking, the mission faced unforeseen technical challenges. During the docking preparation, several reaction control systems, or RCS thrusters, malfunctioned. These thrusters are crucial for maneuvering the spacecraft in space, and their failure raised serious concerns about Starliner's operational reliability. Additionally, helium leaks were discovered in the spacecraft's propulsion system. Helium is used to pressurize the fuel tanks, and any leaks could compromise the spacecraft's ability to maneuver and return to Earth safely. NASA and Boeing engineers are rigorously investigating these issues to determine their root causes and develop solutions. The helium leaks appeared in the spacecraft's service module, which houses critical systems for propulsion and life support, adding complexity to the problem. The impact of these technical issues on the mission has been substantial. Initially planned as a short-duration test flight with astronauts expected to stay on the ISS for about 10 days, the mission timeline has now been extended indefinitely. The astronauts brought up by Starliner may need to remain on the ISS for up to 90 days or longer, depending on the outcomes of ongoing tests and repairs. This extension is necessary to ensure that all systems are fully functional and that it is safe for Starliner to return to Earth. The prolonged stay poses logistical challenges, such as managing life support resources and coordinating schedules with other ISS missions. Furthermore, this delay shows the complexities and risks associated with human spaceflight, highlighting the need for robust contingency plans and thorough testing protocols. While NASA and Boeing work diligently to address these issues, the situation has brought attention to SpaceX's Crew Dragon as a potential backup or rescue option should Starliner be unable to complete its mission. The challenges faced by Starliner exemplify the high stakes and technical difficulties of space missions, emphasizing the importance of ensuring astronaut safety and mission success through rigorous engineering and testing practices. NASA and Boeing are collaborating closely to address the technical problems encountered by the Starliner spacecraft. To pinpoint the root causes of the reaction control system, thruster malfunctions, and helium leaks, NASA has initiated a series of rigorous tests both on the ISS and on the ground. Engineers are conducting detailed analyses of telemetry data and performing simulations to replicate the conditions that led to the thruster failures. These efforts include thermal and pressure tests to assess the integrity of the spacecraft's propulsion system under various conditions. Progress has been made in stabilizing the helium leaks, which initially posed a significant risk to the spacecraft's ability to maneuver and return safely to Earth. Advanced diagnostic tools are being employed to monitor the helium levels and detect any fluctuations that might indicate new or worsening leaks. In parallel, Boeing has deployed additional engineering teams to support the troubleshooting and repair efforts, utilizing their expertise in spacecraft design and propulsion systems. The latest findings indicate that the helium leaks have stabilized thanks to the implementation of temporary seals and pressure management protocols. These measures have successfully contained the leaks, preventing further helium loss and maintaining the necessary pressurization of the fuel tanks. Additionally, of the 28 reaction control system thrusters on Starliner, most of the errant thrusters have been re-evaluated and are now rated for use. Specifically, 4 of the 5 malfunctioning thrusters have been cleared for operational use, ensuring that Starliner retains sufficient maneuvering capability for its eventual return journey. However, one thruster will remain offline during the undocking process as a precautionary measure. This decision is based on thorough risk assessments and the availability of redundant thrusters to compensate for the offline unit. Ongoing efforts include continuous monitoring and testing to verify the long-term stability of the repairs and to ensure the spacecraft's readiness for undocking and re-entry. While challenges remain, the coordinated efforts of NASA and Boeing are steadily progressing towards resolving the issues and ensuring the safe return of Starliner and its crew. In the face of ongoing technical challenges with the Starliner spacecraft, NASA has been exploring contingency plans to ensure the safety of the mission and its crew. One such plan involves the potential assistance of SpaceX, a company renowned for its successful crewed missions to the International Space Station (ISS) with its Crew Dragon spacecraft. If the current tests and repair efforts on Starliner fail to resolve the issues, NASA may need to rely on SpaceX to step in. Industry experts like Scott Walter have suggested that preliminary discussions between NASA and SpaceX about a potential rescue mission have likely already taken place. Such a mission could see SpaceX's Crew Dragon being deployed to either assist in the safe return of Starliner's crew or to provide critical support while further repairs are undertaken. Expert opinions provide additional insights into the feasibility and logistics of a SpaceX rescue mission. Michael Ilbeck, an aerospace engineer associate professor at the University of Illinois Urbana-Champaign, emphasizes the importance of keeping Starliner docked at the ISS to facilitate a thorough investigation of the spacecraft's issues. Ilbeck believes that studying the capsule in situ is crucial for understanding and rectifying the problems. Meanwhile, Scott Walter, a chief technical advisor for visual components in North America, has hinted at the possibility of integrating a rescue mission with the upcoming Polaris Dawn flight, led by commercial astronaut Jared Isaacman. This mission, set to launch soon, could potentially be adapted to assist Starliner if necessary. Walter adds that given Isaacman's willingness to support such initiatives, this could be a viable option. As the technical challenges faced by Boeing Starliner spacecraft persist, space medicine experts emphasize the urgent need for proactive measures to ensure the safety of the mission's crew. Shah Panda, director of the Space Medicine Group at the International Institute for Astronomical Sciences, highlights the critical nature of the situation, warning that delays in implementing effective rescue plans could lead to irreversible consequences. Panda argues that we are approaching a critical tipping point where the window for safe and feasible rescue operations may rapidly close. Immediate action is therefore crucial to mitigate risks and ensure the well-being of the astronauts on board the ISS. Panda's analysis also sheds light on the deficiencies in current frameworks for space rescue operations. Her report highlights significant gaps, including the absence of binding international missions focused on space safety and rescue. Unlike other sectors, such as aviation, where strict regulations govern emergency procedures and rescue protocols, space missions operate under a fragmented framework with limited regulatory oversight. This lack of standardized protocols for space rescue poses challenges in coordinating international efforts and ensuring timely responses to emergencies. Panda stresses the need for regulatory bodies and space agencies to collaborate on developing comprehensive frameworks that address these gaps, including protocols for medical evacuation, contingency planning, and interoperability among spacecraft. The urgency of the situation shows the need for proactive measures to enhance space rescue capabilities and mitigate risks associated with future missions. As humanity ventures deeper into space exploration, addressing these deficiencies in current frameworks will be essential to safeguarding astronaut safety and ensuring the success of manned missions beyond Earth's orbit. One of the primary solutions to enhance space rescue capabilities involves the adoption of standardized docking ports across all spacecraft. Standardized docking ports ensure compatibility among different spacecraft, allowing for seamless connections and interoperability during emergencies. This approach, already implemented with the International Docking System Standard (IDSS), enables spacecraft like Boeing Starliner and Lockheed Martin's Orion to dock with the International Space Station, or ISS, using a common interface. However, the broader adoption of standardized docking ports across all spacecraft, including commercial vehicles like SpaceX's Crew Dragon, is crucial to enhancing rescue operations. By standardizing docking interfaces, space agencies and private companies can streamline emergency procedures, facilitate quicker responses to crises, and ensure the safety of astronauts in orbit. In addition to standardized docking ports, having backup vehicles readily available for deployment serves as another critical measure to bolster space rescue capabilities. The concept of maintaining an additional rocket and spacecraft as a lifeboat positioned near launch pads or in orbit provides a proactive approach to emergency preparedness. In the event of a spacecraft malfunction or crew evacuation, these backup vehicles can be swiftly deployed to rendezvous with stranded astronauts and facilitate their safe return to Earth. This dual strategy of standardized docking ports and backup vehicles not only enhances the reliability and efficiency of rescue missions, but also mitigates risks associated with prolonged missions in space. As space exploration advances and commercial spaceflight expands, continued investment in these solutions will be essential to safeguarding human life and ensuring the success of future manned missions beyond Earth's orbit. And that's all for today's episode. Thank you for watching, and we'll see you in the next one.